Welcome, everyone. I'm Aaron Linemiller. For those of you that I haven't met, I'm the technical account manager for Northrop Grumman and member of the Aerospace and Defense technical team here at Altair. And today we have the pleasure of talking about midsurfacing. So this is historically been one of the strengths of HyperMesh, and I think it's one of the things that draws a lot of people to HyperMesh. I know for me, when I was on the user side, it was one of the things that led me to switching to HyperMesh was the strengths of the mid-surfacing and shell meshing tools. And so I hope you guys will find it to be helpful for your work as well. Just going to share my screen here. Run through couple of a couple of charts, and then we'll do a live demo. All right, so I should be seeing my charts now. So I'm just going to run through a few different workflow tips and highlight the tools that I like to use for mid-surface based meshing. And then, like I said, we'll do live demo and hopefully have some time for Q&A at the end. So in terms of the workflow, the first thing that I would tackle is removing fillets, but it's not super important with mid-surfacing. We talked hex meshing last month, and in a previous session that you can go check out recordings on YouTube, by the way, for all of our previous sessions. And with hex meshing, it can be more important because you're gonna be matching your mesh more directly to the geometry. But with mid-surfacing, it's pretty good at identifying fillets and ignoring them, or just taking the insight that it needs from them and not getting too hung up on them. So, like I say, if it's convenient, I wouldn't spend more than a few minutes trying to pull out any fillets that are easy to pull out. It can help, but it can also, if they're not easy for HyperMesh to defeature, sometimes it can actually make the geometry worse and cause more problems than it solves. So, yeah, just keep that in mind. Then the next thing to think about is mid-surfacing versus mid-meshing. And we have a whole nother session that's going to be dedicated to mid-meshing coming up. And I encourage you guys to check that out as well. I think I see these as very, they're similar workflows, but they're quite different. And so with mid-surface, you're working to create these surfaces that you will then subsequently mesh. Whereas mid-mesh is going directly from solid to a shell mesh, and it's trying to put these elements in the mid planes of your solid. So that's a newer tool. If you're not familiar with it, that's probably why. It's been around for several releases now, and is continuing to mature and develop. So I just jotted down a few strengths that I see in each of these workflows. With mid-surface, I think it's often faster to crank through and crunch through to create the mid-surfaces versus mid-mesh. It's more mature. It's been around for years and years and years. Like I said, it's historically been one of the really strongest features in our workflows in HyperMesh. It's more interactive, so when things don't go exactly how you want them to, you have, I feel like, better control over and interactivity with the process to help guide it back on track. And then similarly, the post edit tools. So if you do an automatic mid-surface and it gets you 80% of the way to your final result, and you need to take it that last 20%, that we have very good tools for taking it that last 20% that again are part of that same tried and true set of tools that HyperMesh has in its quiver. But with mid-mesh, like I said, you get the benefit of not having to deal with the surfaces, the mid surfaces, and so you go straight from solid to mesh, which ultimately that's your goal, is to get a mesh. It's more automatic in that way, but it's also based on the params and criteria that are used for like batch mesher and cleanup tools and other things in HyperMesh. So if you have a set of params that you've fine-tuned for your applications or your organization that you rely on, MidMesh will take advantage of that. And it's developing to be the preferred workflow. I think in the future it will become more and more prevalent over Midsurface. But like I mentioned in the title here, at this stage, what I recommend to people and what I do is definitely try both of them out of the gate. Just take a couple minutes, do the automatic Midsurface, do the automatic mid-mesh, compare and size up how much effort you think it's going to be to take either of them to across the finish line. And in a lot of cases, both of them will work perfectly. And in that case, it's trivial. You can just go with whatever your preference is. Another thing that I didn't mention here as a deciding factor is, if you have a lot of experience with Midsurface, that's a practical consideration as well. Definitely encourage everyone to always be learning new things and all of that. But in terms of, getting your models completed, that's something to factor in. But yeah, I think, and I think there's because of the robustness of the post-edit tools with Midsurface, I recommend if the automatic Midsurface gets you an 80% result and automatic mid-mesh gets you a 90% result, it still might be faster to complete that Midsurface rather than completing the mid-mesh, just based on the availability and robustness of the post-edit tools. So a couple things to keep in mind there. Like I said, definitely check out the mid-mesh session that's coming up soon. And for today, we will focus on Midsurface. So after you do an automatic Midsurface, one of the first things to consider is using plate edit. Excuse me. And so it's right here, right next to automatic. And we'll be doing this in the live demo today, but basically a plate is the building block of a Midsurface. So if you think about trying to create this solid, just using like bar stock, a plate is each segment of bar stock that you would have to use to create that, and each plate is then going to have a Midsurface created for it. And there's different categories of or types of Midsurface or plates that will create a Midsurface in a different fashion. We'll go over those in a little bit more detail during the demo. Also, wanted to highlight the options in the hamburger menu here. These are useful to switch back and forth, as particularly these first two, and as you're editing plates. Next up, once you have finished kind of the mid-surfacing portion of the workflow, you have, again, these additional tools available to get you the rest of the way to your finished product if you need them. And they're really, particularly in the new user interface, these tools for surface creation and editing are really pretty convenient. So my tip here, if you're dealing with a surface that is got some weird stuff going on with it, or it's not quite how you want it to be, but trying to change it is causing issues, or is difficult for whatever reason, plate edit didn't work to get it to behave, don't be afraid to just blow it away and quickly rebuild a new surface. A lot of times that can avoid issues with having bad topology. So even a surface that looks right, once you throw a mesh on it, it might not behave because there's actually some sort of numerical instability in the surface. And so, yeah, whenever you find a surface that is giving you trouble, I tend to want to just delete it and create a new one. And like I said, it's pretty easy with a collection of new tools that we have. So I'll demo some of these in live as well. All right, the next thing I wanted to mention, for those of you that have been around in HyperMesh for a while, you're pretty familiar with these options. They're in a little bit different places now with in the new user interface. but these are both invocable from the visualization toolbar down the bottom of the graphics area. So you can switch to topology mode. If you have if you have the color mode set to automatic, it will go into this automatically when you go into the appropriate tools. But if you're dealing with, like if you're deep in a mid-surface workflow, you may just want to set it to where it's in topology mode all the time. And so you can see it in that way when you're in just idle mode as well. And so there are the color code here. If red edges are free edges, which are not necessarily bad, but if they're in the middle of your part, that's going to be bad, and you want to fix that. Green edges are shared by two surfaces. Again, not necessarily bad or good, just kind of depends on where they're located. Here, that's a good thing. Here, green edge would be a bad thing because there we want it to be actually three surfaces that are sharing these edges. So it's a T-junction, basically. And then similarly, fixed points, some are good. Some of these are bad because they're extraneous. They were just left over from how the mid-surface was created based on probably the fillets that were in the solid. And so we want to suppress those, otherwise they will drive a smaller mesh size potentially than we want. These ones out here are based on defeatured holes. So in that case, I kept those around intentionally because they're fastener locations that I want to preserve. Yeah, so just be mindful of those things and take advantage of those view options. And then the last thing I wanted to mention before we jump into the demo is just kind of my tools of choice when I am approaching a mid-surface based meshing task. So I have a custom ribbon setup, as you'll see, that has all these tools conveniently located rather than being spread all over the place, so I don't have to jump back and forth as much. But obviously the mid-surface tools, and in this case I even brought automatic and edit plates off the secondary ribbon into the top level here, so I can just go straight to them when I want to. The surface creation tools, as well as other surface creation methods. And then also have the splitting tools and defeaturing, and then meshing tools. And I think we'll probably have a little bit of time to even get into the meshing today, because really that kind of goes hand in hand with the mid-surface creation. All right, so with that, let's jump over to the demo. So I got this part that's it's a wing rib, and this is not a production part. It's one that we created as part of our Altair wing demo, but it is fairly realistic. It's got some moderate complexity to it with different fillets in different sizes, different locations. Has some nastiness to it with like some multifaceted. And if you look at this, these are actually different angles that we're in here to match the adjacent spar or whatever it's attaching to. I get some chamfers as well to deal with. And then you have some, I think if we flip it around here, yeah, we have some buildups on the, or pad ups on the bottoms of these areas here that we also need to capture. And then if you look at it, it's also got, some taper to it as well, that just based on the wing or wing OML. All right, so the first thing we wanted to do, or first thing I mentioned in the charts, is would be to defeature. I'm actually going to skip that. I'm going to live with all these fillets just as they are and move straight into mid-surfacing. I'm going to skip the step of comparing how the mid-mesh looks because I know today we want to demo mid-surfacing. So I'm just I'll leave that as an exercise for you guys to do on your own. So I'll just select that solid and mid-surface. You can see the status bar down here will indicate progress with that. It should just take a couple seconds. There are a number of options that you can tweak for mid-surfacing, but usually the defaults are pretty good. There we go. All right, so now at this point, we have, so the solid is kind of in transparent mode. If we, if you look here, you can see the mid surfaces that have been created. And I'm actually just going to hop over to edit plates and say isolate those mid surfaces so we can see them a little better. Or you know what, I'm even just going to hop out of the tool so it hides the solid altogether. Switch into topology mode. Okay, so you can see that it did a decent job. There are some weird things going on here that we need to address. And the first way we want to tackle that is with plate edit. So I'll jump back into plate edit. And I'm going to say color by type. Yeah, let's do that. So I'll turn on my plates initially. The nice thing about this legend here is if you hover over these, it'll give you a visual definition of what each of these plate types is intended to do and the use cases for those. Most of the time, I find myself tending towards planes and sweeps, usually try to avoid offsets. There are a few plates that were created with offset, as you can see here, and we'll probably just change those into planes and sweeps. The other things to pay attention to, albeit somewhat less important, are the surfaces that were identified as transitions and edges. So those are somewhat self-explanatory. You know, edges are just going to be the edges of your plates, and transitions are going to be the, you know, generally the fillets in between plates that are more in, you know, going from the plane of a plate to the plane of another plate. And then you can also just say ignore a surface. So if there's like particularly things like the, you know, these chamfers that may be getting in the way or actually confusing the mid-surface generation, you could say to tell HyperMesh to ignore those. But mostly we want to focus on the, turn those off. Mostly want to focus on the plates and the types and the groupings of those. So if I switch the color mode from type over to the actual plate definition, you can see that in the web of this rib, it actually created 1, 2, 3, 4 different plates. And really, I want all of those to be the same plate, just so to make sure they're talking to each other, one nice planar plate. And then we can see here, so if I say select whole plates, it actually created all of these as one plate for some reason, so we need to break that up. Maybe here as well. Yep, it looped that one in. So let's start tweaking these guys. So I'm going to switch back to selecting individual surfaces, and I think I will get rid of my planes just for ease of picking. So I'm going to pick these 4 surfaces and make that a planar plate. And that's as easy as it is. In this case, I have all my surfaces shown for this complete stiffener. And I'm going to do all those at once. Maybe I might have to flip around. Make that a planar. And then last up is this bottom one here. And it's fairly flat, it looks like. So I can go ahead and make that a planar plate as well. That's a sweep. That's great. So pretty much everything. Let me make sure here. Do I have any other offsets? Okay, that's actually an offset. So I'm going to switch my selection mode back to selecting whole plates just to make it a little faster. That way it'll automatically pick. I got 5 surfaces. We'll just go with that. I think that should have been 4 surfaces, but all right, so that is switched to a swept plate. And so let's bring these back. And we'll go color by, oh yeah, color by plate, that's what I wanted. Okay, so next up, I'm just gonna pick these whole plates and redefine them as one continuous planar plate. And let's go ahead and update our midsurface. So see what those plate definitions, updated plate definitions will do for us in terms of creating a better midsurface. Almost there. There we go. All right, I'm gonna bounce out of context just to see. All right, so this looks much better. Just those few modifications of the plate definitions. So I still have missing component here that we can tackle in plate edit. There's a little bit of funniness going on around these edges where I have this extra surface here, this extra little tab here. This is an artifact, like these little legs here are an artifact of the solid, which I don't actually want that to be, but just based on the fact that this entire face, is continuous, it didn't have a way to break that up. And so we'll do that manually. That's no big deal. These corners actually look really good. Not seeing any red edges in the middle of my part. All the T-junctions are yellow like they should be. Corners are green. Got another little extra tab there that we can, again, delete. I won't do that just yet because you want to finish plate editing before you do any manual edits, because if you do some manual edits and then jump back to plate editing, it will wipe out anything that you've done manually. All right, so I'm going to go in here and see. So in this case, all right, so it picked some, that shouldn't have been a transition, that should have been an edge. That just, I'm going to create a plate here, switch back to surface selection. I'm going to do a sweep. That's going to kind of turn this corner. I need to select the other side too. But I'm also going to show you another way we could tackle this one because it's a little bit tricky. All right, so let's do a sweep there. And go ahead and update our midsurface. All right, so now we have a nice smooth surface around that corner. Again, we have a tab. I think that's coming in because HyperMesh didn't pick up those chamfer surfaces 100% like it should have in terms of edges and transitions. But again, we can come in here and just say, yep, we don't need that surface. We don't need that surface. And we don't need that surface. The rest of these look pretty clean. Okay, so just plate editing made this a nice sweep around that corner. If I wanted to add a feature line there for meshing to dictate the meshing, I could do that. But just for the sake of argument and demonstration, let's say that I wasn't able to fix this with plate editing, or say I want this to be a straight corner instead. So let's just say this is a bad surface for whatever reason, and I need to create it manually. So there's a few different ways you can do this. I think I will do, I think I'm going to grab this edge here and that edge there. And then I'm going to choose my direction to be, actually I'm just going to hold Control to do 3-point selection, grab 3 points. So I'm going normal to that surface there. If I really wanted to be true to the that plate there, I could bring back the solid and use that as a reference, but just for expediency's sake, I'm just going to use that as a reference. And I'm just going to go ahead and overextend that further than I need to. And then I'm going to do the same thing for this one down here. And I'm going to pick those 3 points again on this surface. Yep, oops, come back. And bring that up. All right, then I'm going to use cross extend here. So I'm going to pick these 3 surfaces, cross extend those. And it didn't actually split. Let's try these 2 again. Okay, we'll jump over and do this a different way then. We'll split this surface with the surface. Trim both. Oops, come back. And we'll do the same thing over here. All right, now I can just, I'm just gonna use my, oh, it didn't quite. Well, shoot, I chose a little different way to do this for the demo than I'd practiced, but it's not quite working out. I'm running out of time, so I'm actually going to just jump back and do it the way I had done it before. Always more than one way to skin a cat. So in this case, I'm going to use Split Interactive to grab a couple points there, just to break out that fillet line. And then that'll straighten that up. And then I'll grab those 2 lines, and I'm just going to use that as a guide. That will put that right in there. Much easier. Then I'm going to use patch. So with patch, you can do a few different things. If you do find, it will find any open holes that you might want to fill in. In this case, we don't have a continuous loop around here, but all we have to do is I'm going to click on that edge and hold and drag it over to this edge, and it fills it right in. I'm going to do the same thing on this side. There we go. So now I have a nice square corner there, and there's a little bit of red edge there, so that might be just a sliver surface that I need to get rid of. Whoops. Let's hide that one. Hide that one. Well, based on time, I'm just going to leave that as is for now. Jump to the next step. So I could also come in here and use Split Interactive to trim up these surfaces. I'll just do one side for the sake of time. And then again, once I have those split off separately, I can just blow those away. Last thing I might want to do would be to defeature these holes. I could have done this in the solid, but I kind of prefer to do it in the mid-surface. And I'm going to keep fixed points at the center of those holes. So in this case, I'm just going to say find. It found them nicely. If it didn't for some reason, or if I just wanted to, there's actually 2 different sizes of holes here. So if I just wanted to grab those, I could say find similar and remove those. We'll do these separately, find similar, remove those. Then if I turn on my fixed points, you'll see that got fixed points to those fastener locations that we'll be taking advantage of in the mesh. All right, well, I think I've exhausted my time for today. I have time to stick around for questions if anybody has any. But yeah, if not, I hope you guys found this useful, and we'll be able to leverage it. If you have any further questions about it, don't hesitate to reach out to your technical account manager to talk more about your particular applications. So.